Okay, so can you hear me? Is it okay? Great. So, hello everyone. I'm Jakub, and together with my colleague Patrik, we would like to tell you something about our project we are working on. We will tell you our use case and show you a small demo, and then describe architecture and technology behind. I'm a software engineer. I do some open source stuff, and currently I work for Absa, and Absa is a bank in South Africa. Absa is also steward in sovereign network, which means that we are running the node in a blockchain network, and that blockchain network is an instance of Hyperledger Indy in the open source project. So that's kind of the reason why we are here in Hyperledger conference. So, there are 60 million people in South Africa, and there is a question how to deliver self-sovereign identity solution to all of them. And to be honest, I don't know answer, at least not now, or not yet. But I think we can at least start somewhere, start at smaller scale, and try what does work and what doesn't, and move to higher scale after. And so where to start? I think we can start in existing processes and with existing technology. So banks are already liable for verifying customers' identity. So they need to know who their customers are and what's their identity. This process is called Know Your Customer, or KYC. And in the past, you have to go like physically into the branch and to the bank, give them your documents, ID card, and other documents for like verification of your identity. Nowadays, banks and financial institutions are going to the digital form of this KYC process, where you just upload your documents, take a selfie, and upload it to the server, and then the process is done. So how the self-sovereign identity fits in here? The basic idea of self-sovereign identity is to convert physical paper-based document into the digital form and put the digital signature on it. These documents are called verifiable credentials. And instead of putting them into our physical wallet, we put them into our software wallet, which could run in mobile phone, for example. What's important that we want to like give the user control of its own data and allow the user to decide where to store this data, and decide what and with whom to share this data. What's also important is to have some interoperability and portability in these solutions, because this topic is highly related to collaboration, and I will explain it more in a few minutes. And as I mentioned, that we need to take existing process, that's exactly what we are trying to solve. And we are building mobile application, and we would like to provide the customer or user of the app like possibility to go through this KYC process in a digital form. And actually, there are two workflows. One is fully automatic, when we do some verifications of the mobile phone, ID number, surname, and facial recognition. And if everything goes well, we just issue the digital credential at the end of the process. So if something fails, the user just can upload documents and then go to the branch for face-to-face recognition. But we hope it won't be so much use case. So we hope it will be in a digital way as much as possible. And this is about digital identity credential. It's good enough for a lot of products which the bank offers, but for some products, the user needs to have also proof of residence or proof of his address. So we we want to issue them also proof of residence based on the digital identity credential we issued them in the previous step. And just take data from South Africa database and issue it as a verifiable credential to the user. So as I mentioned, the importance of collaboration, we are not alone in this effort. There is South Africa Financial Blockchain Consortium, which is a consortium of banks and other financial companies, and they are collaborating together on different like use cases or usages of a blockchain for financial services. And one of the use cases is the use case for self-sovereign identity or digital identity. So there is a term, trust over IP, and so you can see on the right we have some DIDs and verifiable credentials, but these are related to technology. So we have technology for the trust, but we still need something from the real world, which is like related to legal stuff around. And it's called like governance frameworks or governance stack. So for us, the governance stack around the blockchain is sovereign right now, but we still need to define like what's the trustable process of the issuance of the digital credential. So we are doing something with our app, but we need it to be like defined by whole consortium. So this is about what should be the credential definition, credential schema for digital identity. What's the correct process? So should we check a phone number or another like email or another verification? And what's good enough for this process to be trustable by other parties? And what I didn't mention is that the idea is to reuse this credential within other banks. So if the user goes through this process with Absa, with our app, then he can go to the different bank and use this digital credential, and he doesn't have to go through this KYC process again. So that's the like first step, how to use it and how to reuse this digital identity credential. So that's about the KYC, but we don't want to stop there, and we would like to provide our users more features. And other like 2 areas of use cases we are currently discussing is, one is the authentication. So we would like to provide digital identity credential to authenticate users in a branch or in a website. And the second, kind of related, is that we want to automate like applications for a new product. When the user go to some website and apply for a new product, currently he needs to fill like endless amount of information into some endless forms. And we would love to offer them just the option to scan QR code and transfer these data automatically from their app based on their credential. So right now, let me just show you a small demo, if everything goes great. So sorry, again. So here is our mobile app. At start, user can select the option for the securing the wallet by Touch ID, Face ID, and that stuff, or just select the passcode. Then there is an option to create new wallet or restore existing wallet from the previous backup. So right now the user is creating the new wallet. And as you can see, there is already secure connection with Absa, with our bank. We do it implicitly on the behind of the user. And from that time, user can start KYC process. So he provides his phone number, and we will send him like some verification code to verify the phone number. actually, we can also issue verifiable credential for the phone number, for example, but separately. Now we need ID number and surname to get information based on this data, to get information from South Africa database. But we also need to verify like the user who is holding the phone. So we do some selfie or face photo verification and facial recognition. And now we will tell the user what data we can provide to him via a credential. And if he confirms that, we will issue to the user digital credential offer with digital identity. And he can save it into his wallet. And as I mentioned, there is a second verifiable credential. Right now, there is no proof request, so we just check whether the user with this connection with Absa goes through the KYC process. But in this step, we would like to use proof request to ask him like for the data about this identity. Okay, and I guess that's it. You can see the user has both of the credentials. And let's look at the second part of the demo. So let's imagine there is some web page with application for a new product in a bank. And you can see there is a lot of information we require from the user to fill into that form. But instead of writing it by hand, the user can just scan QR code with his mobile app. That's the proof request I mentioned before. So we ask him for the data we need to fill into the form. And if he confirms that, we get this data to our backend service securely, and we can also be sure that all of these data are correct. So there is we don't need to do another verification, you know. Currently, the user sends you some data within this form, but you don't know whether you can trust this data. And the user, in this case, doesn't have to be logged into some system. So there is no login. You just scan the QR code and send the data. Okay, so that's from me right now, and I would like to ask my colleague Patrik on the stage.
So, good morning, everyone. Happy that you chose our session. There's many other interesting happening right now. So thank you for your time. I'm full stack engineer at Absa. I work mostly on backend and operation side of things, also doing a little bit of front end. And within the SSI or Hyperledger Indy community, I might be known as the author of IndyScan, which is Hyperledger Indy Blockchain Explorer. Now, in this talk, I'll go a little bit more technical, and I'll tell you about the challenges we faced over time, how we started, and how the challenges we faced influenced our tech stack and our architecture. So in late 2018, we started a simple POC just to show our stakeholders what this thing can do and to get it moving forward. So at the beginning, it was just one single service containing all the KYC business process logic. as well as all the credential related technology. So it was a pretty simple POC, and then after our stakeholders approved, we started to iteratively improving and building on top of that. And this was the time when there was not yet fully formed interoperability standards. So we were a bit struggling to keep up with constantly evolving standards. And however, we still had our own proprietary communication protocol. So we were not interoperable. And soon, there was another member of South African Blockchain Consortium, which was given a Verity UI institutional agent provided to them by Evernym. And they wanted to integrate with us. So we couldn't because the Verity was using their proprietary protocol and we were using our own. So we were not interoperable. So what we did is we looked into this Verity agent and we figured that they are using libVCX. So we tried to, as easily as possible, replace our previous library with libVCX instead. And as we did this, we found out that we can indeed integrate with the Verity agent. So yeah, from the nice outcome of this integration was that we found out that libVCX is really nice to use. So we decided to keep it and build on top of that. So let me tell you just shortly about libVCX. It's a library for verifiable credential exchange. It was donated to Indy project by Evernym. The core of it is written in Rust, but it has bindings in multiple languages, including Python, Node.js, Java, and iOS. So if you are using any of these, you can leverage on all the work that has been put into libVCX. So now I'll tell you a little bit about how we start to adopt this library. So as we replaced libIndy, the core Indy SDK library, with libVCX, we took this big refactoring as opportunity to extract it into a separate service. We call it a VCX service. And the great thing about that was now it became reusable by other team in Absa. And the KYC service basically became a consumer of it. What I did intentionally didn't tell you yet is that out of the box, the VCX, although there's ways around it, out of the box, the VCX is meant to be run against agency. And agency is a well-established term in SSI community. Basically, what agency is a service which can act on behalf of a user. So even when Alice's, here we have, on this example, we have Alice's phone. She wants to receive digital credentials and communicate with various institutions. So Alice will use agency to create her agent, and then this agent will act on her behalf. And once Alice's phone comes online, it can fetch all the messages received in the meantime. So the agency enables cross-domain, bidirectional asynchronous communication between parties. Now, if you use VCX library, you have basically currently two options. You can either use Evernym's proprietary agency, or you can use the open source library, open source implementation of agency. which is in the SDK repo. So the way we started is we want to keep it lightweight, and we just took what was available for free in the repository. We tried to run the open source implementation, and soon we found out that there's various issues because the open source implementation was not meant to be run in production, but it was rather like for integration testing of libv6 library and as a form of documentation. So we started fixing various issues as they came. And for first couple months, it was enough for us. It was enough for us to play with the credentials and try out our use cases. But there was a bigger issues with the agency, and that's particularly related to scaling. So first of all, there's three main points. First was the pool architecture, second file storage, and the fact that this service is highly stateful. And so I'll go now one by one over these issues. So the pool architecture, if you want to DDoS your system, make sure to include polling model in your system. So at first, there was no other way around this agency than to constantly keep querying it, whether it has any new messages. So even if you have just 600 devices online for 1 hour and you try to pull new messages every 2 seconds, that's 1 million requests in an hour, and I find it's very unnecessary. You can also imagine the polling on the other side, the institutional side. So the way we solved this is that we implemented support for notifications to this open source implementation. And so now whenever the agency receives a message, the institution gets a HTTP notification in the form of HTTP request. So then we can respond or react in certain way according to what the message is and from whom it arrived. On the opposite side of the connection, when we as an institution send a message to someone, maybe issuing a credential, this message is sent to recipient's agent, and the agent dispatches notification to another special service down there, the mobile notification service, which converts it into a push notification. I believe there's still a better way to do this. We might not, in the future, might not use push notifications, but rather have opened the WebSocket connection with the agency, and we can avoid, we can make sure we don't leak any metadata in the in the form of push notifications going through Google or Apple. A second problem was that by default, the agency was using the default Indy SDK library wallet implementation, which stores the data in a form of file. And if you want to scale anything horizontally, you need distributed persistent storage. So maybe you could attempt to somehow share these files across multiple nodes of agencies, but I don't find it very elegant approach. So instead, we implemented support for PostgreSQL plugin into the agency. And therefore, now we have our wallet storage distributed. The third problem is that the agency is still very highly stateful. And in order to be able to scale something horizontally, you need to make sure that it's as stateless as possible. So we have plan to make this happen and start scaling this open source implementation horizontally. This effort we'll probably have 3 main stages. At first, we just want to get a lazy load, because the way the agency works right now is that at its startup, it tries to load up all the data from the database into memory. And when we are talking thousands of agents, this startup takes literally minutes. So instead of doing that, we want to bring the load time, the startup time, down to a few seconds. In the second stage, we would like to make it more stateless. So we will start loading the agents on demand. Whenever there's an incoming request for a certain agent, we can load up the necessary state. And after we do state update, we can free this data from memory and keep it in the database. And the third stage will probably consist of some optimization to make this load and destroy quicker. Lastly, this is not a problem, it's a great news. Evernym has recently added support for Hyperledger Aries. So for those who might not know, Hyperledger Aries is supposed to be a global interoperable standard for credential exchange and SSI-based agent-to-agent communication. But truth to be told, we are right now in a bit of we need to make a big decision, because we can either, because the thing about Aries is that it doesn't yet specify how to do revocations, and there's a new revocation implementation coming to in the SDK, as far as I know, this year. So it might take some time till the Aries implementation of libVCX supports revocations. So we can either do that, or we can give up Aries, but have revocation feature available to us. And it seems like revocations are quite important feature for our for the business owners. So we'll have to make this decision. I guess that's all from my side, and I'll let Jakub to close this presentation.
Okay, right. Thank you, Patrik. So just briefly summarize what we have said today. So our use case is KYC as our starting use case. And if you want to build some SSE solution or something with SSI, you basically need some basic elements around DIDs and crypto and credential stuff. But you also need some protocol, how to exchange of these messages. So we started with Hyperledger Indy, and the protocol was just our own and sending HTTP request. And then we moved to VCX, which provided us some protocol also on top of that lower level elements. And as Patrik mentioned, the last step is to move to Aries protocol, which is, because the VCX protocol is just not standard protocol, and it should change with Aries specification, which should be like interoperable for a lot of other agents together. And as Patrik mentioned, what missing is that like to solve this dilemma between revocation and Aries and scaling, and also we need to work, of course, on the UX and UI stuff in our application. And that means that we are not in production yet, but we would like to have some pilot, and we would like to run it with Absa employees this year, and maybe then move to or roll it out to Absa customers. And maybe if I return back to my slide at the start of this talk, maybe we'll be able to deliver it to 60 million people in South Africa someday. So wish us luck, and thank you. And I think we have some time for questions, if you have any. There.
The actual data that you're using there, that's government issued data, right? That's people's identity cards and so on, right? So does that mean the government itself is a participant in your blockchain, or how do you access that data? Where does it come from?
Yeah, currently banks have access to the database of South Africa. So they have access to the database of citizens, and they take the data from the database. So, yeah, I think it's secured, and the access is secured only for the banks. So it's not publicly accessed, but banks need to. They under some regulations, so they need to conform with that, and they have access to it right now.
Can I add a question to that?
Yeah.
In the user enrollment, you take the selfie photo
Yeah.
of the mobile user, and so is that a call to do a photo comparison with the
Yes.
ID card
Yeah.
photo?
Yeah.
And what percentage of those are matching pretty successfully? High number.
I think it's quite good right now, because yeah, it's quite good. What the algorithm we are using right now, it's quite good with this matching. But what's more important for us is this liveness verification. We call it liveness verification. So we need to be sure that the photo is from the user with that mobile phone in that given time, and that facial recognition service works pretty well. So there are some percentage, but I think it's 90%.
Yeah, it's quite high.
I think it's 90%.
Alternatively, there's, I think you didn't mention, right, there's the fallback. If this verification fails,
Yeah.
The user is offered to upload his identity documents, and then once he probably confirms in branch, he can receive his identity credential.
We did some like statistic about it. I don't remember. I think, but I think it was above 90%.
That must be out of the entire Indy stack.
Yes, that's right. That's
Yes,
completely
yes.
yeah.
Okay, and there was a question. Sorry.
So in the demo, you showed how a user could fill out a form, an online form,
Yeah.
right? And so how do you prevent the user then from changing some of that information once it's been validated and inputted?
That's a good question. We actually, when you see the data in the form, we actually have it on our server, and then we just let's say that the data in the form are just for like to show something to the user, and we don't take it after all. So we have it, we show it to the user in the website, but we have it on the server. So if user, it should be disabled in that case, for example, to don't confuse the user.
Just sort of a feedback to the user
Yeah,
that you know the data properly propagated to the backend, so then he can see it in his browser. Yes.
I just think we need to be clear here. DHA, Department of Home Affairs, runs HANS, right? The Home Affairs National Identification System. They expose a service for fingerprint only to authorized banks. I think just to be clear with the folks asking about this, the facial recognition that you're doing and ingest is you're taking a photo of the document, the identity card, national ID card, issued to every citizen over the age of 16. And you are doing a comparison of the live face against the photo that you just took off that. Home Affairs, at least when I was working on some of their efforts, does not have facial matching capabilities. They are aspiring to that. They do not do facial matching. You are doing facial matching.
That's correct.
Okay, that's not what was said here. My question was, when you were doing the enrollment, you were talking about being able to restore an identity. And I'm just wondering, so if I had an identity wallet, as an individual, I'm in possession and control of my self-sovereign identity. But you said we could restore during that registration process. So where is that identity being stored? In Absa?
Okay, so actually, the storage of your identity is in your mobile phone,
Right.
and then if you need to make a backup of it. So you just click on some export functionality, export it, and secure it with passcode, or password, or some passphrase, or something like that. And then, if you want to import it, you just click on the button, select the same file, put the passphrase into that back again, and we decrypted it and put into the mobile phone. So there is, you don't have to go through this KYC process again. I don't know. Does it make sense?
Almost there, but when you click the button to offload your identity information, your very personal identity information, where's it going?
What do you mean by offload?
You said I could back up my identity information from my phone.
Yeah.
Is it going to like my iCloud?
It depends on you. It depends on you.
Okay.
Yeah. So sorry, yeah.
I think
Currently, it's like just file we export it, and it's upon to you where you want to store it. You can put it in iCloud, Google Drive, on your
because there's a concept of custodianship, but I was
Yeah.
wondering if Absa was going to be a custodian in that.
Your libv6 agencies were pretty cool. Is that code you're keeping internal, or is it public somewhere?
Everything's public. We have like tens of pull requests on agency now,
So
which were
GitHub
closed.
Absa,
No. I mean, everything, like most of the work related to the agency was already merged into the agency. It's there. Yeah, that's correct.
Sweet. Okay.
Just thinking about the identity there, how do you ensure that someone's identity is kept up to date? Supposing you have your address changes or your phone number, your database and your system could be out of sync. You have to reload that identity to issue a new identity to update it. How do you keep it in sync?
To be honest, we currently don't focus on this issue. We are aware of it, but it's currently not in the scope to update this document. Yeah. Yeah. Okay. Any other question? Yeah.
So, is this in collaboration with the government, or is this a private entity that is signing the digital?
I would say it's more about collaboration with other banks and financial institutions in this consortium. So we are trying to discuss it with the government, but maybe you can imagine that it's not fast to coordinate this effort. So our priority is at first to discuss it within other banks with this consortium, and then maybe try to collaborate with government. But for this use case, we just need to be able to call the database of the government, and it's possible right now for the banks. So this process and this capability is in place already. So it's not about that we are asking, okay, can we do this or that? We are just using the API that's out there, and the banks is already using it. But we just issue the digital credential based on this information, you know?
In that scenario,
So-
who is the accountable party for protection?
Accountable parties is Absa or other banks for the verification process. Yeah.
In the last pledge presentation, we heard from credit unions aren't in competition the same way the banks are with one another. How open to collaboration have you found the other banks?
Could you repeat?
How open to collaborations we found other banks to be?
You want to answer?
Well, we did as I mentioned, we did some integration testing initially. Then for a while, to be honest, the things were a bit quiet, and now we are restarting. Just recently, we started restarting some efforts with other banks in South Africa.
Maybe what I didn't mention in presentation, I guess, that it should work in vice versa. So we also should accept the digital credential from other bank. So other banks can have their own mobile app, and if the user goes through this process with them, then goes to Absa, and we should like accept this credential. So yeah, then it depends what's the trustable process of doing this verification. So yeah.
I think we are on time.
We don't have it like to have it like this is our solution and we are only one company who is doing that. That's not the case.
Okay, I think we are out of time. Thank you,
Thank you
everyone for your time. Thank you.